But let's move on though. I think after a few examples, it might start to click. You may have to think about it for a bit also. I mean, when I was a math student, that's how I was. Nothing ever came easy to me, so. All right. Let's consider this one now. Okay. So here, let's suppose now we have a bag of marbles, okay? There are 10 red marbles in there. There are 5 blue and 8 black. So in other words, there's 23 marbles in there, right? And again, just like before, it's fair in the sense that if you were to reach into the bag, you cannot tell by feeling the marbles, but not looking at them, what their color is. You know, it's not like the red ones feel differently than the blue ones. Okay, and we choose a marble at random, okay? We note the color, but then we put it back, and then we choose a second marble. Okay, so again, let me say it again. We're reaching into the bag, we take a marble out at random, we note the color, you know, we write it down or whatever, we put it back into the bag, then we randomly choose another one. So we're going to let A be the event. The first marble is red. That's the event. Okay. Now we're going to let B be the event that the second marble is also red. And now we want to know, are A and B independent? Again, we want to know whether A occurs or not, will the probability of B be affected? Well, yeah, we could go through this whole rigmarole, I think that's the right phrase, of, you know, going through the sample space and all that stuff. But if you think about it logically, you would see that, yeah, A and B are independent. The probability of one is not going to depend on if the other occurred or not. But let me say it this way. The probability of B occurring, okay, that's not going to be affected by whether A occurs or not. Because, for instance, the probability of event A, right, that's 10 out of 23, there's 10 red marbles in there, and there's 23 altogether, right? But we're putting that marble back into the bag, right? So when we're picking a second marble, right, when we're choosing a second marble now, there are still 23 marbles in the bag, right? And there are still 10 red ones. So the probability of B, that's gonna be 10 out of 23, whether the first marble we chose was red or not. Okay. Oh, actually, here we go more into it. So logically, you know, we should see that, yeah, both events are independent. But now we're going to just show that, we're going to verify that though. But really, again, I'm trying to show here that if you just think about it, well, yeah, they should be independent. I mean, we'll see later that if we did not put the first marble back, we held on to it, then they're not going to be independent. But let's show rigorously that they're both independent, okay? I mean, we're not going to list all the possible outcomes, but what's nice here is we don't have to. So for the first marble, okay, let's let A be the event that the first marble is red. B is the event that the second marble is also red. What was the probability of A? Well, we know that probability is 10 out of 23. You know, just like before. Okay, so let's suppose the first marble was red. Oh, I was wrong. Then not. Oh no, sorry, this is different. I'm sorry. My mistake. This is a different example. Here we have a bag of marbles. We have 10 red, 5 blue, and 8 black. Okay? Now here, again, just like before, they are indistinguishable except for color. So just like before, if you were to reach into the bag and choose one at random, you would see that the marbles, you can't distinguish their, you can't feel if they're red or not. You know, the red ones feel like the blue ones, so to say. Okay. So we're going to let A be, so we're choosing a marble at random. And notice we're not putting it back. We're then randomly choosing a second one. Okay, so this is not the same as this example. So I misread my slides. I apologize for that. Here we're choosing a marble at random, but we're not putting it back though. Okay, this is different, you see? We're not putting it back. So now A is the event the first marble is red, B is the event the second marble is red. Okay? Now the question is, are A and B independent? Well, remember, this is not like the previous example, right? In this example too, we chose a marble at random, we put it back, then choose a second one. Here, we're not putting it back. Well, let's see what happens. We have the probability of the first marble, right? That's just going to be 10 out of 23, right? There are 10 red, there's 23 marbles altogether. Okay? But we're not putting it back, so we're holding on to it, right? The marble we chose. Well, if that first marble was red, what happens then? Well, then there are 9 red marbles left, right? Remember, we chose a marble. We have it in our hand. If we chose a red one, there's 9 red marbles left. And not only that, there's only 22 marbles altogether. So now the probability that the second marble we choose is red, it's 9 out of 22, right? Since the first marble was red, okay? And there's 1 marble left. There's one less marble in the bag, that's right. The event here is 9 out of 22. Okay? The probability here, that is 9 out of 22. Now, what if the first marble, though, was not red? Well, if the first marble, though, was not red, okay, if it wasn't red, then, if it was blue or black, well, there's 10 red marbles still in the bag, right? But we're still 1 marble less. So there's only 22 marbles here. There's 10 red, but there's still only 22 marbles. So now the probability of B, that the second marble is red, is 10 out of 22. But notice, but the point is, though, do you see how the probability of B is affected by whether A occurs or not? Right? So A and B here are not independent. A and B here then, right? They are not independent. They're not. Good. Good. Okay. So here, since the probability of B is affected by whether A occurs or not, if A occurs, we get a probability. But if A does not occur, we get a different probability. So the events are not independent. Are there any questions on that? Any questions at all? Yeah?
Yeah, I'm just like a little confused because it's like 10 out of 22, right?
Right.
So what marble is, but
Because we
isn't
chose a marble that was not red, that's why.
but isn't one of the marbles that are taken out what's
No,
making
here
it
we're
9
assuming
out of
that
22? And then if you have 10 out of 22, wouldn't it would be 23 again? Like,
no,
that's why I'm a
because
little confused.
here we're assuming that here first, we're assuming that A did occur. And so if A occurred, we chose a marble that was red. So now there's 22 marbles there, but we only have 9 red remaining. So this is how we got this probability.
Yeah.
Right? But here we're saying, what if the first marble, though, was not red? So if it was blue or black? Well, there's 22 marbles left, but there are still 10 red ones.
Oh, okay. So they're just 2 separate.
Exactly.
Oh, okay.
We're saying, what if this occurred? And here we're saying, what if this occurred? So.
Oh, okay. Oh, I see. You said, and the bag has 22. Okay, I didn't read it fully. Sorry.
That's okay. That's okay. No worries. No worries. Good question. Any other questions? Okay. Let's move on then. So here we have another example, okay? Let's suppose now we're going to roll a 6-sided die twice, okay? So we're going to roll a 6-sided die twice. You know, we roll it, note the number, then we roll it again. Now, we're going to let A be the event that the first roll we got a 5. And B is the event that we get a 3 on the second roll. Okay? Now, let's say are A and B independent? Well, I mean, we could go through the sample space, right, and list all the possible outcomes. But if you just think about it, you're rolling twice, right? Each time you roll, you know, you're not taking a number off the die or anything like that, right? Each time you roll, there are 6 equally likely outcomes, right? There are 6 possible numbers you can roll. They're all equally likely. So because of that, A and B should be independent, right? I mean, just think about it. What's the probability of A? That's going to be 1 out of 6, right? But when you roll the die the second time, you know, when you roll it to get a 3, whether or not you got a 5 on the first roll is not going to make a difference. You're going to roll a 3, the probability would be 1 out of 6. I hope that makes sense. So we're saying here that they are independent. Okay, does that make sense, what I'm trying to say?
Yes.
Yeah, it makes sense.
Let me just do that poll thing. I feel better asking. Wait, oh, not that. Okay, does it make sense? I mean, hopefully it does. Maybe I'm just like over-explaining it because I do that sometimes. Because I really want everyone to understand this. So, okay. Okay. Well, come back. Okay, so I guess everyone gets it. Okay. I mean, it's really not that hard. It shouldn't be that hard to see why. I mean, because, you know, you're rolling the same die twice, and each time you're not losing an outcome or gaining more outcomes. So it really shouldn't be that hard. Yeah. All right, let me share the screen. Okay. Okay, so I mean, I just figured I'd do it this way because, I mean, theoretically, you could list the sample space, but again, it turns out there would be 36 members in there. I mean, that you could list them. That's not terrible, but I wouldn't want to list that.